Accepting that your child will go through life missing a hand is difficult for any parent. Maybe my reaction was so powerful because Sol wasn't born this way. This was something that shouldn't have happened to him. Watching a newborn baby's hand die slowly just leaves a mark on you. And what happened to Sol changed me forever. I was introduced to prosthetics through an accident that happened to my son during his birth. We think because of a forceps injury, Sol's arm was crushed during delivery, and sadly 10 days later in a specialist unit in Old Age Children's Hospital in Liverpool, he had to have his left arm amputated. He lost pretty much everything below the elbow on the left-hand side. My experiences as a father and my own research led me to identify quite a few areas where there was a shortfall between what was being offered by the NHS and what I thought was optimal, what was a better solution. I was worried that if Sol didn't wear a device daily that he would soon learn to get by without, and I was aware of a whole catalogue of problems that could come downstream from that. The first consultation with the NHS, our healthcare provider, was basically a message to say, look, Sol may never wear a prosthetic, the chances are he won't, most children don't. Come back in a year and we'll see if it's something that you can try with him. Everything inside me was just screaming, that's wrong, that just can't be right. I see this huge gap between what was being offered and what was optimal for my son, and I just decided I was going to do something myself. Like everyone else, I'd seen Enable and Team Unlimited and these 3D printed downloadable arms that strap on and hey presto, you're supposed to transform your life. The clinical reality of living without a hand and what these devices offer is too stark to go into here, but ultimately I knew that they weren't safe. At the other end of the scale we have the medical devices, which are certificated as safe for use, so that gives you peace of mind, but often these things were hideous to look at, creepy or just downright awkward to use. So I was really worried that if Sol didn't wear a device and get used to wearing a device well before it came time to fitting a myoelectric, that he just simply wouldn't engage with it. I wanted him to see that there are benefits to having a prosthetic besides the bit that we all latch onto. We all focus on the opening and closing hand, but he was missing a limb, and a limb doesn't just open and close, it supports your weight, it provides balance, it's something that you can fall on and push and suspend yourself with. That was really, really important to me. I wanted Sol to know that he had something on his arm that wasn't going to fall off, that wasn't going to smash to pieces. Yes, it wasn't going to be able to do all the things his other hand could do, but it was the very best and safest that we could offer using modern technology. I formed Ambionics because I wanted to make sure that I was always close to the heart of the matter and always able to meet my son's needs, but I also felt a compulsion to help other children too. I felt really strongly that things weren't being done the right way, and that thousands of children around the world, as well as Sol, were going to miss out unless I acted, unless I brought these ideas that I was having to life. Tell us about the spiders. Okay, the other thing that we're really well known for is a unique solution to being able to provide a functional grabbing. Borrowed the idea from spiders, where we're using fluid pressure to control the grip. Now, spiders don't use fluid pressure to control the grip, but they do use it in their legs to straighten them. So when a spider bends its legs, it uses muscles, and then when they flick back to their straight position, the leg is just basically flooded with blood, and that pressure straightens the leg. So it's a use of hydraulics, the use of fluids to convey pressure from one place to another. Luckily, some big companies had seen what I was trying to do. Autodesk put me in touch with a design engineer. They also hooked me up with Warwick School of Engineering, new materials, new methods, new techniques, a whole load of stuff about 3D printing that I had no idea about. Aras Components too also donated all of the filament that I would need. And finally, Microsoft, when they picked up the story, they flew the whole family out to Vegas. And there on stage, about a year ago today, we were given £20,000 to try to get across the line. So this all got me to a point where we had a pre-production prototype and a globally recognisable brand. So glad now to be part of the team working with Glaze, where this idea and many of the other ideas that I've had will now be explored, reviewed and hopefully pursued. Being unable to secure any funding here in the UK, we announced on social media that we were in trouble and number of companies contacted us. We looked at the different possibilities of collaborating. It was a no-brainer. At the end of the day, the DNA between ambionics and glaze prosthetics was just too similar to ignore. Glaze was the natural fit. Innovation is in our DNA. They've got the same passion, the same style, and the same, Glaze believe in my ideas. And it's taken a lot of time to get the scientific community to listen up to what I've been saying, but here we are now. Universities are now taking it seriously. But it's Glaze that have helped me in terms of actually being able to deliver this as a product in the market. It's basically a bath full of nylon powder, and then lasers melt that nylon together to make an incredibly strong, robust and virtually indestructible socket. So it's only 1.6 millimeters thick. It's feather light, incredibly strong and customized to the user. We do this by working with prosthetists. So the prosthetist may make a liner for the inside of the socket. We will then connect the ambionic arm around that, working with the prosthetist. We're also working directly with families and have experimented with direct limb scanning and scanning casts. So we're bringing the best, if you like, of the conventional technology and the disruptive new Industry 4.0 technology. So the features of the ambionic hand then. So we're looking at making products for all age groups. Everything from what we call our functional passive, and the functional passive just features a spring-loaded thumb that can be manually operated, through to cable-operated devices that are either voluntary close or voluntary open using a harness, and of course our own patented hydraulic technology and hybrids thereof. So one of the things we're really interested in making is a cable-operated hand with a hydraulic thumb and a myo-operated rotational wrist. First thing to do to start the process is to get in touch. So just send an email to hello@glazeprosthetics.com or reach out to us on our social media, Instagram, Twitter, Facebook, etc. From there you'll have a prosthetist appointment that will be local to you, and we can advise and recommend, but this is going to be something that you do, so please do look in your area. If you live in a country like the UK, you can contact the NHS and ask them if you can go private just to get the prosthetic socket done. But we can look at different options with each individual depending on where you live. So after the prosthetist appointment, the prosthetist will make a cast or a thermoplastic molded liner. Once we've got it all done and lined up and the measurements are taken, the next thing to do is print it, post-process it and send it out to the user for testing.